Okay, so now we will be moving ahead with angles and direction measurement in survey. Okay, first thing that I would like to clarify, what is the difference between angles and directions. The angle, when we are talking about, it means suppose we are stationed at a particular point. Okay, when we are doing survey with reference to a particular station, or you can say with reference to a particular benchmark station at which we are standing. So what we need to do, suppose we need to get the angle, the horizontal angle, if we are talking about in horizontal plane between any two stations, suppose A and B. So firstly, from that point where we are stationed, we will try to sight station A, and then we will try to sight station B so as to get the angle between those two stations. Okay, that included angle that we are talking about is the angle between those two stations with reference to that station where we are standing. So this is the angle. When we are talking about direction measurement, that direction of any particular line is mentioned with reference to a certain reference. Okay, a reference meridian, or you can say a reference axis. Suppose that generally a compass, if we are talking about compass surveying, a compass that we use generally gives us the direction with reference to the northern axis. Okay, with reference to, if we are talking about prismatic compass, so prismatic compass generally marks the northern, the needle which is there in prismatic compass, it always points towards the magnetic north. So from that you will get to know where is the magnetic north of the station located. Okay, of that site where you are stationed, where is the magnetic north, in which direction it is pointing, and then you can sight any line. Suppose you are sighting any line AB, so you will get to know that yes, this AB line is at what angle from the actual magnetic meridian, that axis which points towards the magnetic north, with reference to that what is the angle of the line of which we are talking about. Okay, so this is the direction, because from here with reference to the actual reference axis, the reference meridian, that is the northern axis, with reference to that northern axis we are getting to know that what is the angle any particular station or any particular line is making with reference to that reference axis, which we consider as northern axis. So this is the direction. Okay, angle generally is denoted by the magnitude, and direction is whether in northern direction, southern direction, northeast, northwest. These are the direction measurement. Okay, so both of this data is required for us so that we can get to know the actual behavior of the line and the direction in which this angle is being made. Okay, so now firstly I will give you an idea about the various systems that prevail in which the angles are reported. Okay, the first two that are reported here, basically in India all the calculations that are done are either in Radian system or the Sexagesimal system. But I will introduce you about all the four systems that generally prevail in which the angle measurements is done. Okay, first one is the Radian system. Okay, Radian system, what we do, we assume that the entire circle is divided into 2 pi radius. Okay, as you know, the Sexagesimal system, that is the second one, if you remember, means this is the most common system that we use in India here for angle measurement. It says that a complete circle, if you see the angle for the complete circle or for one complete revolution, the angles that are made is 360 degree. At any particular point, if you complete one complete revolution, so for one complete revolution of a circle, the angle that it will traverse will be 360 degree. This is the Sexagesimal system. And similarly in Radian system, this also you would have studied, that I was talking about first. What it says, that entire 360 degree which we are talking about, one complete revolution of the circle, that is generally considered as 2 pi radian. Okay, so these are the most prevalent systems that we talk about in India. Rest, next one is Centisimal system. This is used more or less in UK. In UK generally they use Centisimal system. In this what happens, they divide the entire circle, or for entire one revolution they divide it into 400 grades. Okay, one complete circle is divided into 400 grades. Even thereafter there means divisions have been made. As you remember in Sexagesimal system, apart from degree, we remember that 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. So the complete angle that is reported in Sexagesimal system is in degree, minutes and seconds to complete accuracy. Similarly in Centisimal system, what happens, the angle that is reported, one complete revolution of circle is considered as 400 grades, and 1 grade is equal to 100 centigrades, and 1 centigrade is equal to 100 centigrades. Okay, so they also divided into 3 parts. First is grade, then is centigrade, and then is centigrade. Okay, and the last one that is very rarely used, they use in military systems, it is used somewhere. What they do, they divide the entire circle into 6400 mils. Okay, So what happens, one complete revolution of a circle that is 360 degrees sexagesimal system, it is considered as 6400 mil in millisystem. Okay, so these are the few conversions that are basically used throughout the world, so you should be having an idea. In most detail we will be talking about radian system and sexagesimal system only, and I will also show you the conversions how they can be made, so that you at least have an idea that how these calculations can be done and in what angles they are being splitted. Okay, so firstly, one by one we will discuss something about all those four systems that generally prevail. First one is the radian system. Okay, in radian system, as I already told you, that one complete revolution of a circle in radian system is divided into 2 pi. Okay, so 2 pi, where pi, as you all know, it is equal to 22 by 7. If you report the value of 22 by 7, that we generally consider as 3.14159. Okay, so this is 2 pi, one complete revolution. In this, what it says, that 1 radian is that angle which is subtended by an arc whose length is equal to radius of the circle. So whatever is the radius of the circle for which we are talking about, the arc length when it goes same, okay, the arc length when it goes same as the radius of the circle, then whatever will be the angle subtended at the center will be considered as 1 radian. Okay, this I am trying to tell you that how does the concept of radian evolve. Okay, so what is 1 radian? 1 radian is basically when the radius of the circle, whatever will be the radius of the circle, if we consider the arc, okay, the arc that we are talking about, if that arc is also of the same length that is equal to radius of the circle, then the angle which will be subtended at the center will be equal to 1 radian, as I have tried to show in this figure also, where you can see the radius of the circle is equal to r and the same arc length is there. Okay, so if same arc length is there, then the angle that will be subtended will be equal to 1 radian. Even you would be knowing the formula also that you would have studied in your 10th or 10 plus 2, that any arc of circle is defined as the radius into the angle enclosed by it. So if arc length is s, then s is equal to r into theta. Okay, and if we substitute the value of s as r only, because we are considering the arc length equal to radius of the circle, then r is equal to r theta, that will give us the value of theta is equal to 1. Okay, so that angle is generally reported as 1 radian, and since the circumference of the circle is 2 pi r, so for every r length on the circumference of the circle, every r length that we are talking about on the circumference of the circle, so total number of these r lengths that will be existing on the entire circumference will be 2 pi times. Okay, 2 pi times if this r occurs, then only our total circumference will be equal to 2 pi r. So total number of arc lengths that we are talking about will be equal to 2 pi. So you can see when we talk about radian system, so total radians that you will be substituting will be 6. You will be able to substitute completely, and then you will be left with some quantity, because 2 pi is around 6.28 something. Okay, so 0.28 radians you will be left with. Okay, so this only you need to remember, that one complete revolution that is being made by in radian system at the center of the circle is 2 pi radians. Okay, and how it comes, how does we define 1 radian? What is 1 radian? It is the angle that is subtended by an arc of a circle whose length is equal to the radius of the circle. Okay, so that angle which we are talking about is generally considered as 1 radian. So this I have tried to show you here also with the help of figure. If you can see, if r is the arc length, then and r is the radius of the circle, and if we consider arc length as same, then the angle which is subtended is equal to 1 radian. And with this concept you can see towards the right hand side of the figure, so total number of arcs of length r that you can find in the circumference of the circle will be 6, and you will be left with certain angle that will be equal to 2 pi minus 6 towards the bracket. Okay, when you complete 6 radians starting from here, 1, 2, 3, 4, 5 and 6, then certain angle will be left that will be less than 1 radian. So this will be equal to 2 pi minus 6, because you have already completed 6 radians, and this angle that was coming at the center was equal to 2 pi. And how we get to know this angle is 2 pi? Because the circumference of the circle is given by 2 pi r, and we have completed every arc length is of length r. So total number of lengths that will be requiring of length r on the circumference will be 2 pi times. Okay, so 2 pi is the angle that will be subtended, and hence you can find that the total angle that will be subtended by for complete revolution of circle in radian system is equal to 2 pi. Next we will see how you can find angles. I have given certain examples so that from here you can get to know that whether you can calculate these angles in radians. Okay, you should have an idea, and these are some basic figures which you should be able to do by your own. Why? Because there will be certain angles of these types that will be made. Okay, when we will be discussing and when you will be in the field survey. So what we basically do, the field side that we are doing survey, we try to divide it into different trapezoids, because mostly what we prefer doing is close traversing. When we are doing close traversing, then we try to divide our field side, for which the stations that we are considering, into pentagons, hexagons, maybe triangles for better accuracy, or rectangles, squares. So for this, if you are measuring the angles, then you should at least have an idea for regular figures that what are the angles that are being made, and those angles you should be able to report in both the systems, either sexagesimal or we are talking about, or the radian system if we are talking about it. So from here you can see that this angle, if we are talking about one complete revolution, that means we are talking about 2 pi radian, one complete revolution of a circle. Similarly, if you have to suppose it is a case of equilateral triangle, then every angle that will be made will be equal to 60 degree. Okay, 60 degree is how much? 60 degree is equal to pi by 6, because every pi is equal to 180 degree. It's a simple case, you can remember, because we know that one complete revolution in radian system is equal to 2 pi. Okay, one complete revolution, if it is equal to 2 pi, and in sexagesimal system it is 360 degree. So 2 pi denotes 360 degree, it means pi will denote 180 degree. Okay, so if we are having this angle as 60 degree, then 60 degree, when you have to convert this into radian system, then it will be given by 60 into 2 pi by 360. Okay, you just need to make the ratio of 2 pi by 360 each time you want to convert sexagesimal system angle into radian system. So this will be 60 into 2 pi by 360. If you solve this, this will come as equal to pi by 3. Okay, similarly, if you want to report this angle, you can see it is a case of right angle triangle, 90 degree. So 90 into 2 pi by 360, this will be again equal to pi by 2. Similarly, you knew that if it is a case of equilateral triangle, that this angle should be equal to 60 degree. Okay, it is 60 degree, and from the center its bisector is running. So this angle that we are talking about, this small angle that is shown with red color, will be 30 degree, which is equal to pi by 6. Okay, because 30 into 2 pi by 360, again it is equal to pi by 6. Similarly, if we are talking about rectangle, then we know this angle is 90 degree. Similarly, this angle should also have been 90 degree, this complete angle, if you would have been talking about at the top left corner. But what is happening, since the bisector or the diagonal is running, that 90 degree angle will be splitted into two halves. So that angle which they have shown at the top left corner will be equal to 45 degree, which can be reported as pi by 4. Okay, 45 into 2 pi by 360, if you calculate its value, this will come out equal to pi by 4. Similarly, what you can do, the outer angle, if you are trying to calculate this outer angle, what will this be? Since inner angle for a square or a rectangle is 90 degree, so this outer angle will be equal to 270 degree. Why it will be 270 degree? Because we are talking about one complete revolution. If the inner angle is 90 degree, so for one complete revolution to occur, it should be 270 degree, because 270 plus 90 is equal to 360. So 270, when you try to convert in radian system, 270 degree into 2 pi by 360, this will come equal to 3 pi by 2. Similarly, for any other figure, suppose we are talking about pentagon, I will show you for any random figure, and thereafter you can calculate for any angle. Okay, suppose this is the case of pentagon we are talking about. Pentagon is a figure which has got 5 sides. Okay, if this is the case of regular pentagon, firstly the summation of included angles within any regular figure can be easily found out. Okay, it is given by n minus 2 into 180 degree. Okay, or you can say n minus 2 into pi. Okay, where n is the total number of sides a regular figure is having. When we are talking about pentagon, so it has got 5 sides, then this should be 5 minus 2 into 380. Okay, or you can say 5 minus 2 into pi. So 5 minus 2 is equal to 3 into 180 is 540 degree. So So total summation of included angles of a regular pentagon will be equal to 540 degree. And now if this is a case of regular pentagon, so all the 5 angles that will be enclosed will be of equal magnitude. Okay, so 540 you can divide it by 5, you will get 108 degree. 108 degree will be the angle. So 108 degree, these all inner angles that we are talking about will be 108 degree. Okay, so you can see at the bottom right corner or at the bottom left corner of a pentagon, this angle that we are talking about is equal to 108 degree, and this angle you can convert either in sexagesimal or radius. If you want this angle in radian, then you can just multiply this value by 2 pi by 360. Similarly, the top angle that is shown in case of regular pentagon, since we know this inner angle is equal to 108 degree and the total summation of angle at any particular point should be equal to 360 degree. So what we need to do, from the entire 360 we will subtract as 108 degree. So the angle which we will be getting will be 252 degree, that outer angle. Okay, so that outer angle is 252 degree. Now we can multiply it by 2 pi by 360 to get its value in pi. Okay, similarly, if we want to get inner angle at the center of that pentagon, the angle that is being subtended by its diagonal, so we can easily get, since it is a case of pentagon, so if we draw diagonals from each of the edges or each of the vertex, then what will happen, total 5 substitutions will be there at the center, or the center angle of 360 degree or 2 pi will be divided into 5 equal parts. Central angle complete is 2 pi. This 2 pi angle will be divided into 5 equal parts. So each part will account for 2 pi by 5. Okay, 2 pi by 5, or you can say if you want to convert it into a degree system, then it is 360, and 360 by 5 will be the angle that will be substituted. Okay, now you can easily calculate its value, that will come out equal to 72 degree, or you can say directly in radian system as 2 pi by 5. Okay, so this is how the angle measurement goes for each and every figure. The only thing that you need to know, first thing you should be knowing that how we can calculate the summation of included angles formula. It is given by n minus 2 into 180 degree, or you can say n minus 2 into pi, where n is the total number of sides a particular regular figure is having. Once you get the summation of all the sides, summation of all included angles, you can divide it by total number of sides that it is having to find the angle for one particular side that is substituted there. Okay, so if we are talking about hexagon, obviously the angle that will be substituted will be 6 minus 2 into 180, that is 4 into 180, which will come out equal to 720 degree. Okay, after this 720 degree angle can be divided into 6 equal parts because there are 6 angles. So 720 upon 6 will be 120 degree. This 120 degree angle is being substituted in case of regular hexagon. Okay, and if you know this, then outer angle you can easily get. This is inner angle is 120, so 360 minus 120 will be equal to 400. 360 minus 120 will be equal to 240 degree. Okay, similarly if you want to get the angle that is substituted at the center, so 6 arcs are there that are substituting the angle, but total angle that will be substituted at the center will always remain equal to 360 degree or 2 pi. So that 2 pi can be divided into 6 equal parts, so it will be 2 pi upon 6, that is equal to pi by 3, or you can say it will be 360 upon 6, that will be equal to 60 degree. So these are how we can measure the angles in different systems, and once we have converted in one system, they can be easily converted if we have got good knowledge about the conversion systems. Next comes sexagesimal system, that is most commonly used and we have heard of it. What it says, see, firstly the only thing that we need to remember in sexagesimal system is one complete revolution when we complete for a full circle, the total angle that will be substituted at the center will be equal to 360 degrees. Okay, or you can say 1 degree is equal to 1 by 360 of a complete turn, because one complete turn is making an angle of 360 degree. So 1 degree will be equal to 1 by 360, means if 1 by 360th part of a complete revolution we are taking, that angle which will be substituted at the center will be reported there as 1 degree. Okay, and it is one of the most commonly used measurement system that is used. In this, what we do, 1 degree is splitted into 60 different equal parts that are known as minutes. So you can say 1 degree is equal to 60 minutes, and 1 minute is again divided into 60 equal parts that are known as seconds. So each minute has got 60 seconds attached to it. So you can say, if we want to report angle, the angle that it is reported is shown as I have shown in the last bullet point, as you would be already knowing also. 20, suppose we have to write a particular angle in sexagesimal system which is of the form 20 degree, 40 minutes and 23 seconds. So it will be written as it has been shown. 20 degree is written at the top, then 40 minutes is shown by one dash, and 23 seconds is generally reported with two dashes. Okay, why I am telling you? Because most of the equipments, they measure the angle. The angles that are generally reported are in this form only. So when you see an angle, at least you should be having an idea that what it is trying to portray and what it is trying to depict. Even in the field survey which we will be conducting, we will be reporting the angles like this only, whatever will be the angle between two stations. If it is measured in sexagesimal system, it will be in degree, minutes and seconds form. Okay, next comes one more important thing. If any angle you are having in sexagesimal system, that is in the form of degrees, minutes and seconds, and you want to convert that angle into decimal form, okay, because for calculation purpose sometimes it is required that the angle which you are talking about should be reported in decimal format. So what you can do, any angle that is given to you, okay, suppose any particular angle you are having, it is in the form of 20 degree, 43 minute and 20 second as we discussed. So if you want to convert that particular angle in decimal system, firstly you will write the degree part, that is 20 degree, you can write that separately. Then whatever is the part of minute, suppose it is 40 minute, so that minutes part has to be divided by 60, because 1 minute has got 1 degree has got 60 minutes. Okay, so that minutes part you will have to divide by 60, and that seconds part, the angle that has been reported in seconds, that part you will have to divide it by 3600, means 3600. Why? Because 1 degree has got 3600 seconds, because 1 degree has got 60 minutes and each minute has got 60 seconds. So 1 degree has actually got 3600 seconds also. So if you are trying to convert the entire angle into degrees in decimal format, so minutes will have to be divided by 60 and angles that are reported in seconds will have to be divided by 3600, that is 3600. And then you can add all these three values to get the final angle reported in decimal degrees. Similarly, what happens? Suppose at times you are having the angles in decimals and you want to convert it in this degree, minutes and seconds format. So what you can do, any angle that is given to you, I will try to show you this with the help of an example also, both ways, so that you get an idea, because you should be having an idea, because this is one of the most widely used unit, and in this only all the angles are reported and the conversions are made. Okay, so what is happening? See, if any decimal degree or decimal angle is given to you, maybe in the form of 20.475632, okay, if it is some random value that this much degree angle is reported to you, so what you do, the decimal part that is given even before the decimal, means the angle part that is given before the decimal, if it is 20.4732, then that 20 portion, that integer portion of the decimal degree will be the degree, angles in degree. If you are trying to get the angle portion in minute, so whatever is the decimal degree, means entire angle that is written after decimal, suppose it was 20.4722, so 0.4722, this is the portion after decimal, this you will have to multiply by 60. Once you multiply this portion by 60, the value which you get, okay, that integer part of that value will be reported as minutes. Okay, suppose after multiplying it by 60 you get the value as 43.732. okay, so the decimal part that you get will be the the integer part that you will be getting here will be the minutes, and the final portion after the decimal you are getting in minutes. When you multiply that portion by 60, so the final value now you will be getting will be the angle in seconds. Okay, this I will try to show you with the help of an example so that you can get a better idea. Okay, and in this you need to remember that only the seconds angle can be in decimal, and other than that the angle that is in degrees and minutes will always have an integer value. It can't be in decimal. However long the value of an angle is in decimal format, when it is reported in degree, minutes and seconds, only the angle that is written in finally in seconds, if you are requiring very good accuracy, then only that can exist in decimal format. Rest everything will exist in integer value only. This I will try to show you with the help of a figure also. Okay, what we are trying to do, suppose we are given with any angle, it is given as 23 degree 34 minutes and 32 seconds. This angle has been given to us in sexagesimal format, in degree, minutes and second format, and now we need to convert this in decimal value. So what we can do, see, entire angle that is written with degrees, that will exist as it is, so it will be 23 degree. The angle that is given in minutes will have to be divided by 60, so it will be 34 by 60, and the final angle that is given in seconds, you will have to divide it by 3600, so 32 seconds by 3600, and then you add these all three values. So the final angle that you will be getting will be the 23 degree 34 minute 32 second when it is reported in decimal form. So when you solve this value you will get as 23.57556 degrees. Now suppose this angle you need to convert back into the degree, minutes and second format. So what you do, the portion in 23.57556, this angle which you are having, the integer part in this value will be the angle in degrees, that is only 23. Then for next portion to get the angles in minute, what we do, the portion that is existing after the decimal, that is 0.57556. Okay, that you can also obtain by subtracting the actual angle from that degree. Okay, I mean that from 23.57556, when you subtract this 23 degree, you will be left with only 0.57556. So we are talking about only that angle that is after the decimal. You need to multiply that value by 60. Once you multiply that angle by 60, the value of the angle that you will be getting, okay, suppose in this case we are getting this as 34.5336. So you need to get only the integer value of this angle. When you check the integer value, this integer value is equal to 34, so it will be 34 minutes. And if you check, it is coming the same as we did. Okay, it should be 23 degree 34 minutes and 32 seconds. Even you can check back the calculations with the help of your calculator to be pretty sure. Okay, next, finally, the minutes angles which we have assumed, which we have got, okay, it is 34.5336. In that portion, the decimal value that was existing after decimal in the minutes angle, okay, so it was 5336. Okay, so this 5336, this value which we are getting 0.5336, when we multiply this value again by 60, okay, we get the angle in seconds also. So 0.5336 when multiplied by 60 gives us 32 seconds, and the final angle, if we write for 23.57556, it will be 23 degree 34 minutes and 32 seconds. So this is basically the conversion from decimal format to degrees format, or from degrees format to decimal format. Okay, so you should have an idea, because sometimes we need to do the calculations in decimal format. Next, I will deal with them very fast because they are not very widely used in our country, and at most of the places only Radian system and Sexagesimal systems are used. So this I have already introduced you. What is Centisimal system? It is also referred to as metric system. Though most of the calculations we do in metric system, this is the actual metric system that exists. In this, what happens, the entire circle is divided, entire one complete revolution of a circle is divided into 400 equal parts that are known as grads. Okay, it is shown by a small g as superscript. Okay, after the angle is written, then it is shown as a superscript at the top. So if we are writing suppose 360 grades, so it will be 360 and g will be written after it as a superscript at the top of 360. Okay, so it has got total, as in Sexagesimal system we have got 360 equal divisions as 360 degree, it has got 400 equal divisions as 400 grads, and in that each grad is divided into 100 equal parts. So one grad is equal to 100 centigrads. Okay, that is written as centesimal minutes. Centigrads we mean centesimal minutes, and it is shown by small c, that again acts as a superscript to the actual angle that we are talking about. And 1 centigrade is divided into 100 centigrades. Okay, so it is shown with the help of cc, centesimal seconds. Okay, these are the seconds, previous one were the minutes, and these are the seconds. It again has got 100 equal divisions, and in this the conversion is very easy. If any particular angle it is given to us like this 35.453342 grads, and we need to convert this angle into grads, centigrades and centigrades, then what we can do, this angle will be reported as 35, the angle that is written before the decimal, it will be 35 grads, and then thereafter 0.553342. so firstly it will be 45 centigrades, and then 33.42, that value which is left, centigrades. So every time actually what is happening, this value is being multiplied by 100 instead of 60. Okay, so if the value you will see after decimal, that is 0.453342, you multiply it by 100, you will get 45.3342. so the decimal part for integer part for this will be 45 centigrades. And similarly afterwards 0.3342 that is left, if you multiply that again by 100, you will get that as 33.42 centigrades. And last one comes the mill system. In this, as I already told you towards the start of session, this system is mostly adopted by military for artillery purposes, and what they do here, the one complete revolution of a circle is divided into 6400 equal parts, and that is shown as 1 mils. Okay, each part, each subsequent segment is known as 1 mils. So you can say if we divide one complete revolution of a circle, then 2 pi radians should be equal to 360 degrees, should be equal to 400 grads, and should be equal to 6400 mils. Okay, so this is the basic conversion that exists, and this is where I have tried to show that I showed you towards the starting of this presentation also, that how the conversion and how you can get track of all those 4 systems that generally exist and that are generally used in various parts of the country, so that you can get to know that what is the basic conversion and how you can convert from one system to another system. Okay, you just need to take the ratio. Okay, if we are given the angle in radians and we need to get it in degrees, minutes and seconds, we just need to multiply that angle by 360 upon 2 pi. Okay, any angle that is given in radian, if it is to be converted in sexagesimal system, just multiply by 360 by 2 pi, and if that angle is given in sexagesimal system, you want it in radian, just multiply by 2 pi by 360. Okay, in whichever you are converting, take the numerator as the same and denominator of the other system from which you are converting. Okay, next, the angle measurements. So 2 angle measurements that is basically required in surveying, now we will be discussing. Okay, first one is the horizontal angle measurement, and next one is the vertical angle measurement. But before that, for measurement of any angle, 3 things are required to us. Okay, if we have to measure any angle, 3 basic things are required. First one is the reference line, or you can say reference plane, or the reference meridian, with respect to which we have to measure the angle. If any angle we are measuring in surveying, then that particular angle which we are measuring has to be with reference to a certain plane, certain axis, certain line, or certain reference we need to consider, with reference to which we will be measuring the angles. Okay, first thing that is required is the reference line. So whatever will be the systems we will be studying in which angle measurement is basically done, for that we also need to know the reference line that is being used, with reference to which the angles are reported. Second one is the sense of turning. With reference to that reference line or the reference plane, the turning means the angle we will be taking in which direction. Either it will be clockwise or it will be counterclockwise. This also we need to get track of, then only we can measure the angle. And the last one obviously is the magnitude of angle. Okay, only if these 3 things are known to you, then only you can report an angle. If any one thing is not known to you, then also you can't report the actual angle or the actual direction in which the survey has to be done. Suppose you don't know sense of turning, you have been given, you need to take, reference line is given, suppose it is northern axis, from the northern plane you need to take an angle of 60 degree, magnitude is also given of 60 degree. So you can't report the plane unless it is told that 60 degree which you need to take should be in clockwise direction or anti-clockwise direction. Okay, or you can say if magnitude of angle is not known, sense of turning and reference line is known, then how will you measure the direction of a line? And if the reference plane is not given, then obviously it is not possible to start, because from where you will start taking that clockwise direction and that particular angle. So all these 3 things should be known to us. Based on this, 3 types of angles we generally study in surveying, the angles that are given. First one is the horizontal angle. Obviously, what is horizontal angle? Horizontal angle is the angle measured in horizontal plane. Okay, if you are measuring or if you are doing the survey on any particular ground surface, then all the points that will be existing on those ground surface, okay, all those particular points, if for any field you are conducting the survey, all the points that will be lying on the ground surface of that field, if you want to calculate the angle between these different stations lying on the ground surface, then the angle measurement that you will be doing will be in the horizontal plane, and that those angles will be reported as the horizontal angles. What is vertical angle? Vertical angle is when one point is on the ground surface and the other point is elevated at certain height. It may be tower, bottom of the tower and top of the tower. So the angle which you will be measuring now between the top and bottom of the tower will be the vertical angle. Or if you are talking about tree, or if you are talking about any building, okay, so the bottom and top of the building, the angle which you will be measuring between that will be the vertical angle. Next comes the zenith angle. Zenith angle, when we are talking about, it is always reported with reference to the northern axis. That angle will be always taken from the up plane. It is fixed that you will be taking the zenith angle from the up plane. Even you can see here, if any line AB that has been shown in this figure, the zenith angle that has been reported is with reference to the axis that is inclined towards top, or you can say northern axis. Okay, the angle that is measured in vertical plane, for that is shown as the zenith angle, and for any horizontal plane angle that we are talking about in horizontal plane, the zenith angle for that will be equal to 90 degree. Okay, so the zenith angle generally is shown from 0 degree to 180 degree. If this angle is from 0 to 90, it means we are doing the calculations above the ground surface, and if it is from 90 to 180 degree, it means that we are talking about angle of depression, that is below, the angle is going below our line of sight. Okay, so this also, these three systems we will be discussing one by one when we will be moving ahead. Firstly, let us start with horizontal angles. Okay, what are the horizontal angles? Horizontal angles are obviously measured on a horizontal plane with reference to certain reference line that is in the horizontal plane. Okay, means the thing is clear. We are talking about the horizontal plane, and any angle that we will be talking about with reference to any horizontal line of axis or any horizontal meridian, with reference to that, if we are taking the angle, then that angle which we are talking about is the horizontal angle. Even you can see in this figure the line OA which has been shown. With respect to origin, a line OA has been drawn, and its angle with reference to northern axis has been shown as the horizontal angle. Okay, so it is perfectly in the horizontal plane, and when you measure the angle in the horizontal plane, all those points which we are talking about, the angles between them will be reported as the horizontal angles. In the field survey, as I already told you, if you are taking the angle between any stations, those are located on the ground surface, so all the angles that you will be reporting with reference to one station to other station will be the horizontal angles. Okay, all those angles are the horizontal angles. For horizontal angles that we make in the horizontal plane, two things we need to know. First one is the backside line, and the second one is the foresight line. Now I will give you an idea what is backside line. Firstly, see, suppose what is happening, actually we are stationed at a particular point. Okay, suppose we are doing angle measurement with the help of any instrument. Suppose we have stationed the theodolite over our tripod at a particular station, and we consider this as the origin of our survey. Suppose this point is point O. Okay, now we have got two stations from this point. First station is station A, and the second station is station B. Okay, they are located on ground surface in two different directions. So firstly, what we will do, from point to measure the angle between station A and station B from origin O, we need to firstly sight one point. Okay, the first point that we sight, suppose we are sighting from this point, we have placed our ranging rod at point A, and from origin O, where we have stationed our instrument, we will try to sight the ranging rod at station A with the help of telescope that is installed in the theodolite. Once we get track of that, what we will do, we will fix our vernier caliper at that place. Okay, we will fix our reading, we will clamp the screw so that our instrument is tightened at that particular point. And now what we do, we will move our instrument axis from that position when our axis has been fixed. Now what we will do, we will not allow our vernier to rotate in that direction initially. We will fix our instrument. Now what we will do, from that O position, now we will try to sight the ranging rod that is at station B. Okay, at OA we have fixed the zero of our vernier, and now what we are doing, from origin O, we will try to sight another station, that is station B. Now our zero of our vernier is fixed at station OA. So with reference to that, the amount by which we will be moving, this will show the angle OB. Okay, and what is this angle OB? Means from O to B, when we are making an angle with reference to origin OA, with reference to initial line OA, so that OA that we made was the back side reading. For that back side, the initial angle was fixed, and now we will be making a foresight reading at another station B, and with reference to that which will be measuring the angle. So the angle that we will be getting now will be the angle AOB, that is the angle with reference to the initial station O where we have mounted our instrument. We will get the angle between stations A and B. Okay, so the initial ray that was made at a particular point was the back side, and the final side that is made will be the foresight. And the intersection of these two angles where it occurs, from where we are trying to measure the angles between these two stations, that is known as the actual station where we have mounted our instrument. So those points will also be known as the stations, but this is the actual station, the benchmark station where we have installed our instrument, and with reference to which we are taking the angles between those two sides which we are talking about. Okay, so this is the concept of horizontal angle measurement. Now horizontal angle, that is measurement that is done. For that, two basically means systems are used for measurement of horizontal angles. First one is whole circle bearing. Okay, now this is very important because as I was talking about compass, so in two compass that exist, first one is the prismatic compass and the second one is the surveyor's compass. So the prismatic compass, this will be understanding towards the end of this presentation, because it is very much important that before means understanding that how we can measure angle with the help of any equipment, we should know that the angle which it is reporting, what does it depicts. Okay, so prismatic compass, if you would be having an idea, it basically gives us whole circle bearing. That is the angle from 0 degree to 360 degree. And in last surveyor's compass, it gives us the quadrantal bearing, means that angle which it will be reporting will be an acute angle that will be between 0 degree to 90 degree, but it gets us to know that this particular angle which we are talking about lies in which quadrant. Okay, whether it is in northeast direction, northwest, southeast, southwest, whichever is the quadrant, it will let us know, so that we can get an idea that in which direction this angle is pointing. So this we will get to know one by one. So for that, it is very much necessary that we should have a very good idea and we should develop very good understanding of the two horizontal angle measurement systems. First one is the whole circle bearing, that is also known as the azimuth. So azimuth is shown from 0 degree to 360 degree. What it does, see, three things were required. First thing was the reference line or reference meridian. So for measurement of azimuth or the whole circle bearing, the reference line that is used or the reference axis that is used is the northern axis. From origin, in the direction the north of the needle will be pointing, or where the north axis, with reference to that whichever angle is made, okay, that angle is known as azimuth, and this angle rotates clockwise. Okay, from north, the clockwise angle that will be made will be the whole circle bearing, and this angle may range from 0 degree to 360 degree. So it is the angle that is measured with reference to the northern axis, that is considered as the reference meridian. So we have got the reference meridian. The angle that will be measured will be in clockwise direction. So always you need to know that whenever we are talking about whole circle bearing, if it is given that a particular line is having whole circle bearing of 45 degree, it means that particular axis which we are talking about, that particular angle which we are talking about is inclined at an angle of 45 degree from the northern axis in the clockwise direction. So this angle may range from 0 degree to 360 degree. It can have any reading. Okay, so any angle that will be between 0 degree to 90 degree, since from north we are measuring in the clockwise direction, so any angle that is from 0 degree to 90 degree is in northeast quadrant, that is the first quadrant. Any angle that is between 90 to 180 degree is in southeast quadrant, or you can say second quadrant. Any angle that lies between 180 to 270 degree will lie in this southwest quadrant, and the final angle that lies, any angle that whose whole circle bearing is from 270 to 360 degree, that angle will be lying in the fourth quadrant, or you can say it will be in northwest direction. Okay, so for each direction that has been shown here, you can see north has got whole circle bearing of 0, with reference to which all the angles are measured. this east has got whole circle bearing of 90 degree, south of 180 degree and west of 270 degree, and this is also reported as the azimuth of a particular line. Okay, so here you can see, even if you have been asked to calculate azimuth of few lines, I am talking about 4 lines that I have tried to show here. First line is O1, okay, 0 1 with reference to origin 0 1. Suppose this is the line which makes an angle of 52 degree with reference to northern axis. If it is required to calculate the azimuth of this particular line, so this line will have an azimuth of 52 degree only, because this angle has been given to us from northern axis. But suppose this line we are talking about 0 2, so this line is making an angle of 59 degree with reference to southern axis. So if its whole circle bearing we require, so this line that we are talking about 0 2, its whole circle bearing will be this angle. Okay, so this will be 180 minus 59, because this entire angle should have been 180 degree, and since this angle is given to us as 59 degree, so the angle that will be left with reference to northern axis in clockwise direction, that will be 180 minus 59. If you try to solve it, this will come out equal to 121 degree. 121 degree. Next comes line O3 that has been given, and it has been given for line O3 this angle is 22 degree with reference to southern axis, and we need to calculate the whole circle bearing of this line. So obviously, since it is lying in third quadrant, that is southwest quadrant, so its angle should be in between 180 to 270 degree. And how you can calculate this angle? This angle can't be 22 degree because this is with reference to southern axis. And if we are talking about azimuth of a line, we always need to report the angle with reference to northern axis. So with reference to northern axis, the angle which this line is making is 180 this much plus 22. So it will be 180 plus 22, and if you solve this, this comes out equal to 202 degree. And finally, for line 04 that we are talking about, its angle with reference to north is given as 35 degree, but this angle which is given is in anti-clockwise or counterclockwise direction. And the angle the azimuth generally reports, or the whole circle bearing, is generally it is in clockwise direction. So what we need to do, from 360 degree, this entire angle was 360 degree. With reference to this 360 degree, we need to subtract this 35. So 360 minus 35, when we talk about, it comes equal to 324 degree, and this particular line will lie in northwest quadrant. So you can even see that the final line that we are talking about, if it is lying in northwest quadrant, its angle that we are talking about will be lying between 270 degree and 360 degree, and you can check this angle is coming out, the whole circle bearing for line 04 is coming out equal to 325, that is obviously lying between 270 to 360 degree. So this is how you can calculate the azimuths for a particular line, and you can get to know that in which quadrant particular line will be lying. So even just for your understanding, I have given few angles so that you can get to know that from these angles we can get to know that particular line, or a particular line which we have portrayed on the field side, if it is given by any compass, by suppose we are using prismatic compass, and we have been given that this particular line is making an angle of 120 degree with reference to the northern axis, that is shown the magnetic north on the prismatic compass. So what does that 123 degree depict? It depicts that with reference to that northern axis in clockwise direction, an angle of 123 degree has been made. It means that the particular line which we are talking about, since this angle is greater than 90 degree and less than 123 degree, so we are in the second quadrant, and that second quadrant denotes that we are in the eastern direction and in southern direction. So the second quadrant, you can see it depicts southeast quadrant. Okay, first quadrant, suppose 87 degree is the angle. This angle is an acute angle that lies between 0 to 90 degree. So the angle here we are talking about is in the first quadrant, and first quadrant denotes northeast. Similarly, 245 degree, if you talk about, it comes in 180 to 270, in between 180 to 270 degree, that is in third quadrant, which is southwest quadrant. And the final angle of 341 degree, if you try to see all the angles have been reported with reference to the northern axis in clockwise direction. Okay, though this angle may have easily been reported from northern axis in counterclockwise direction, but since we don't only need to report the angles, but these angles should be reported in the way so that we can read them out directly and can get to know the alignment of a line at a particular site. So if the prismatic compass gives us an angle of 341 degree, it means the particular line with reference to which the line of sight we are making, if we are getting an angle of 341 degree, it means that line is lying in northwest quadrant. Okay, so northwest quadrant easily depicts the area, and we can get to know that in which direction we need to make the survey, okay, or in which direction our particular line is lying. Similarly, you can check for all the other cases. Hopefully by the end of this you should have got a good idea of how we can get the azimuths or whole circle bearing. Next one, last application of this is we can even calculate azimuth of a line from point coordinates. Suppose we have already laid the line, we have calculated the distance, or you can say the coordinates of the stations are known to us. Suppose there is line AB, the line AB, the point A has got coordinates of 50, 70, and line B has got the coordinates of 80, 100. Okay, so from that we can get to know that what is the horizontal difference between those 2 points and what is the vertical difference between those 2 points. Okay, you can see here by E and N what we generally mean. E denotes the easting, it means how much you are inclined towards east, and N denotes the northings, it means how much you are going towards north. Okay, so northing, easting, southing and westings are the term used. Okay, where northing is basically in y direction the reading that is taken, and easting is in x direction the reading that is taken. In surveying we write it as northings and eastings. So if a particular line, for a particular line you know the coordinates, initial point 1 is having coordinate of suppose E1, N1, and second point is having coordinates of E2, N2, then what you can say, based on these coordinates you can easily depict the horizontal distance between these 2 points. That will be the difference of eastings, which I have shown here as E2 minus E1, and the difference in northern coordinates, or you can say in y axis, the difference between their coordinates you can easily determine N2 minus N1. So you know the difference in northings, you know the difference in eastings, so you can easily calculate the angles considering it as a right angle triangle case, because each line wherever it is inclined you can easily form the right angle triangle based on the readings of eastings and northings. Once you know this value of delta E, that is in horizontal direction, and delta N, which is in vertical direction, you can easily calculate tan alpha. If you are measuring this angle with reference to the vertical axis, it will be given by delta E by delta N, because tan theta is given by perpendicular upon base, and if you are measuring the angle with reference to vertical axis, so the perpendicular will be delta E and the base will be delta N. So you can easily get tan alpha is equal to delta E upon delta N. With reference to that you can calculate the angle alpha. Okay, so this can be used for checking the measurements in your survey if any particular field plot has been drawn and whose coordinates has been determined, and if not, you know, it can be vice versa also, you know the angles or the direction of each and every station with reference to one station, the angle of other station, or the bearings you know, and you know the distances. Based on that, using cos and sine rule, you can easily calculate the station. Okay, so this can be used both ways to calculate. Okay, and from this we can easily calculate the whole circle bearing or the azimuth of a particular line. Okay, even if that line is lying in which coordinate, that can be also determined. Okay, suppose as I took an example, suppose first station has got a coordinate of 20, 30, and next station has got a coordinate of 40, 10. Okay, so 20, 30 first station means its easting is 20, and the next station that we are talking about 40, 10, its easting is 40. That means second point is lying more towards eastern side. Okay, now if we check, first point has got the northing of 30 because it was 20, 30, and next point has got 40, 10, so 10 is lying below 30. It means that particular station, the second station which we are talking about, is towards right, means it is towards eastern side and it is below. Why? Because it has got the northing coordinate of 10 and initial point has northing coordinate of 30, so it is lying below. So the line which will be connecting both these stations from 20, 30 to 40, 10 will be lying in the second quadrant, that will be southeast quadrant, because that line is going downwards, and if we measure the whole circle bearing with reference to northern axis in clockwise direction, then that particular angle will be lying in second quadrant, and this angle that will be reported will be greater than 90 degree, from 90 to 180 degree. You can easily measure the angle. Tan alpha is the difference between delta E upon delta N. So this angle that you will be getting with reference to southern axis now, because this angle is lying below, So since this angle is with reference to southern axis, so from 180 you can decrease that angle as we saw previously. Simple mathematics will go, and you can easily calculate the, means you can do these back calculations to determine the angles once the coordinates are known to you. Okay, so these we can do. And what is the next thing that comes is, if the angles are known to us, we can also calculate the coordinates. As I told you, suppose this line length is known to you from 1 to 2, it is 100 meter, and this angle is known to you, suppose it is 30 degree. Okay, so if angle this 30 degree is known to you, so this northing will be 100 cos 30, and this easting difference between these two stations will be 100 sin 30. Simple, you can use Pythagoras theorem using cos and sine rule. If the angle and the slope hypotenuse is known to you, using tan, sine theta and cos theta, you can easily calculate the northing and easting difference between those two stations. And if the station point of any one point is known to you, based on that you can calculate the points of all the other stations. And once you calculate the coordinates, you will get a very good idea that with reference to the initial benchmark station where all the points are located in the field. Okay, with reference to the initial benchmark station which we are talking about, where all the stations are located on the field, you can get to know the distance between those two stations, you can get to know the angles between those various stations. Okay, so this is how this concept works. Next thing that comes in this series is calculation of back azimuth. Okay, what is back azimuth or back angle or back bearing that we are talking about? Suppose for line 1 2 we have calculated the angle. Okay, if that angle is alpha 1 2, then back bearing of line alpha 1 2 will be equal to alpha 2 1. Means if we are measuring from 1 to 2, then back azimuth means we need to measure same line from 2 to 1. Okay, if this is 4 bearing from here to here, then back will be from 2 to 1. You can see the direction of measurement is shown. From 1 to 2, if we are taking the measurement, it will be 4 bearing or 4 azimuth, and if we are measuring from 2 to 1, it will be back azimuth. So alpha 1 2, if suppose an angle from station 1 to station 2 we measured with reference to the actual northern axis, it came as alpha 1 2. So now if we are measuring the same angle from station 2 to 1, it will come as alpha 2 1. Then how we can calculate from alpha 1 to what will be the value of alpha 2 1? So this you can easily remember that the difference between the 4 bearing and back bearing is always equal to 180 degree. The difference between the actual 4 bearing and the back bearing, the 4 azimuth and back azimuth of a line is always equal to 180 degree. This you always need to remember. Okay, how you can see, you can even check it here. See, suppose I have drawn this line and I have tried to extend this. So if alpha 1 2 is this angle for line 1 2, this will be the whole circle bearing for this line. And now when you try to measure for line 2 1, okay, if you try to measure for line 2 1, then with reference to actual northern axis, the angle which you need to report is this complete angle. This complete angle that you will show from 2 to 1. Okay, so this angle will be how much? Alpha 1 2 was this much. How? Based on the concept of corresponding angles. See, if this is alpha 1 2, then this line is going parallel. Since these two lines are intersecting parallelly, so this angle should also be equal to alpha 1 2 based on the concept of corresponding angle. If this is alpha 1 2 and we have increased this angle by 180 degree because this is a straight line, so 180 plus alpha 1 2 will be angle alpha 2 1, which is the back bearing of that line. So back bearing of any line with reference to 4 bearing is always added by 180 degree. But in this you need to remember, if that angle exceeds 360 degree, by adding 180 degree, if that particular angle which we are talking about, it exceeds 360 degree, it means that you need to get excess angle only. Okay, means suppose you added 180 and that angle become 400 degree, then that angle of 400 degree can be reported only as 40 degree. Because when you complete one complete revolution, then you can again start from 0. Okay, so angle 361 degree is equal to 1 degree, because you can subtract 360 degree as soon as you have exceeded that. Okay, so this is the concept that goes. I have tried to show this with the help of an example also. Okay, here you can see, suppose I have taken any azimuth of a line as 50 degree. Okay, if 50 degree is the azimuth of any line, then the back azimuth of that line will be just 50 plus 180, that is equal to 230 degree. Similarly, if we are talking about azimuth of 150 degree, then the back azimuth of that line will be 150 plus 180, that will be 330 degree. But now if we are talking about an angle of 210 degree, that is any line is making an angle that is shown here as with reference to origin. You can see this line OC. If we are trying to talk about this, so what is happening? If this line we are talking about, then this line is making an angle greater than 180 degree. Okay, suppose we consider that the azimuth of a particular line is 210 degree. Then what will be the back azimuth of that line? This should be 210 plus 180, which will come out equal to 390 degree. But since this angle is greater than 360 degree, so we need to subtract 360 from this, and the actual back azimuth of this line will be 390 minus 360, that is equal to 30 degree. Similarly, for azimuth of 330 degree, same concept goes there. If we are talking about azimuth of 330 degree, again if you try to add 180 here to get the back azimuth, so 330 plus 180 is 510 degree. So from that 510 degree you need to subtract that 360 degree, which is an extra. When you decrease that 360 degree, so 510 minus 360 comes out equal to 150 degree again. So back azimuth of any particular line, that is 330 degree, will be equal to 150 degree. Okay, so this is the concept to calculate the back azimuth. Now comes the second concept of quadrantal bearing.